example. So this would be a couple examples, I guess. This would be a good time for you to try some on your own and then come and check back in. I know at least some of them aren't too bad, so good practice here. Okay, so all of these we're trying to find dy dx, which means in all of them the first step should be take the derivative of both sides with respect to x. Oops, this is a minus. Alright, so if I want to take the derivative of x cubed with respect to x, that's actually the easy part. That's just a normal 3x squared. When I get to the y cubed, it's a little different because we're thinking function cubed. So it's going to be 3 times function squared, and then I have to chain out the derivative of that function. On the other side, I see an x times y, so this will be a product rule, and I would like to just mentally hook that 6 to the x. So I'm going to have the second y times the derivative of 6x with respect to x, which is just a 6. And then I'm going to have the first 6x times the derivative of the second, which is the y prime. And then I will need to get my y primes on one side isolated. So I'm going to leave the 3x squared where it is. I'm going to subtract off a 6y. Then I'm going to leave the 6xy prime where it is and add this 3y squared y prime. Okay, so rearrange a little. And then we need to, I see two things. Okay, so we need to factor out a y prime is the big one. The other one I'm seeing is that everything is divisible by 3, and I kind of like to just get rid of that, but we'll wait. Okay, so we're going to factor out the y prime, and we'll be left with a 6x plus 3y squared. So we get that y prime is equal to 3x squared minus 6y over 6x plus 3y squared. And then I'm going to go ahead and factor that 3 out and cancel it. Okay, so 3 is gone, and my answer is x squared minus 2y over 2x plus y squared. Okay, so there is the first one. Second one, similar start. If we want dy dx, then take the derivative with respect to x. This one actually looks really easy because the x's are on one side and the y's are on the other. Okay, so the derivative of sine y with respect to x should be a cosine y times y prime. Do not forget the chain on that. And then the derivative of y is y prime. The derivative of x cubed is 3x squared. And the derivative of x is 1. I think this one is a little easier. So I've already got my y primes isolated since my y's were over there together. I'm going to factor that out. So I'll have a cosine y plus 1 times y prime, which means y prime is equal to 3x squared plus 1 over cosine y plus 1. Okay, last one. This one looks a little more interesting. Xe to the negative xy equals y squared. So derivative with respect to x Okay, so this is a product, so let's do the second, e to the negative xy times the derivative of the first, which is just 1, and then we'll have the first times the derivative of the second, which is actually kind of a mess. So e to the stuff is its own derivative, but then there's a chain rule, and the chain rule is on a negative x times y, so we're actually chaining out a product rule. So we'll have y times the derivative of negative x, which is negative 1, plus negative x times the derivative of y, which is the y prime. And that's going to equal the derivative of y squared, which is 2y times y prime. Don't forget the chain. Okay, so my next goal is to get y primes isolated on one side, but right now I have a problem because this y prime is stuck in the brackets. So first I'm going to distribute. I'm going to say I have e to the negative xy minus xy e to the negative xy. So I'm distributing this whole thing through. And then it's going to be another minus x squared y prime e to the negative xy equals 2yy prime. Alright, so now that it's not stuck in parentheses, I'm going to go ahead and move that one over. So I have an e to the negative xy minus xy e to the negative xy, and then I have a 2yy prime plus x squared y prime e to the negative xy. And I factor out my y prime, so e to the negative xy minus xy e to the negative xy equals 2y plus x squared e to the negative xy times y prime, which means that y prime should equal e to the negative xy minus xy e to the negative xy over 2y plus x squared e to the negative xy. And I was just getting honestly think I'm done, but I'm realizing as I look at this that there's actually one more step. You're not supposed to leave negative exponents. So it's actually pretty quick to fix. If you think about this as a 1 over e to the xy in each of those three spots, really all you need to do is multiply everything by an e to the positive xy. When you multiply e to the negative xy by e to the positive xy, you get e to the 0, which is 1. So when we do that, here I'll sneak it in up above, I guess. We get 1 minus xy times 1 over 2y e to the xy plus x squared times 1. So that actually simplified really nicely. And I just remember that it needs to be those negative exponents. Alright, thanks for watching. I will post group works for this again. I know you guys don't get to work in groups, but if you want some really challenging practice, it's good to have. There's definitely good practice on your homework, but I put some really hard, messy ones. So if you want to challenge yourself, it will be showing up. You don't have to turn it in and absolutely use it and check answers. And if you want to, you can post it on forums. Alright, thanks for watching.